and logic statements and their different forms. Conditional and logic statements are useful tools that we can apply in geometry because many of the theorems that we can devise, like the interior angle theorem or the Pythagorean theorem, which you may have heard of, depend on the foundations of conditional and logic statements. So, in this video, we're going to establish that foundation with a simple example here. So our base example sentence that we're going to start with is, if I am hungry, then I will look for food. So this is our conditional statement. We're going to go ahead and underline this here because this is the base form. It's the conditional state. That's what we call this. This is the primary, the logical, or conditional statement. Okay, this is kind of like our starting point here. And the symbolic reference for this, a symbolic reference is basically the symbol or term we use to describe this relationship, is shown as P, then arrow points to Q. And where P is our condition, the P is the condition that we depend upon to get to Q. So in this case, P is, I am hungry. That's the condition. Then Q is, I will look for food. That's what's going to happen if I'm hungry. If I'm not hungry, then we're going to see what happens. But if I am, then I will look for food. That's the logic of this conditional statement. And this is a true statement because usually if you're hungry, you're going to go searching for food one way or another. So we're going to go ahead and mark this down as the statement being true. Okay, so here we have our second statement. If I look for food, then I'm hungry. So as you can see, this is the reverse of the first statement, and we call this a converse statement. And all this is literally just the reverse of the first statement. And as such, the symbolic notation for this statement is going to be Q to P. And again, our Q is the same as it was before, I look for food, and our P is again, I'm hungry. It's swapped, different order. Now, does this make any sense? If I look for food, then I'm hungry. So this might not always be the case, is the thing here. It's unlike with the first statement, it isn't always going to be true. And since that's the case, we cannot conclude that this statement is true. So we must write false because there are possible conditions in which this could be false. So we have our third statement here. If I am not hungry, then I will not look for food. So this is a little bit interesting because you have the order of the first statement, but you're negating both. We have a not in front of both P and Q. Not hungry and not look for food. So there we have the inverse there. So this is the inverse statement. And all this is just the reverse. It's the negated form of the conditional statement. And we can write this by saying tilde P goes to tilde Q. And the tilde just basically means not or inverse. So not P, not Q is what we're saying here. Not hungry, not look for food. And does this make any sense? If I'm not hungry, then I will not look for food. So this could be true, but again, there are conditions in which this could be false. And as a basic logical principle, the inverse and the converse will never be entirely true, which means they must be false. So we have our last statement here. If I am not looking for food, then I am not hungry, it says. So here we have both changed the order and we've negated the terms and changed the order. So this is called the contrapositive statement. And what we've done here is we've reversed the terms as we did for the converse statement, but we've also did what we did for the inverse statement, and that is negate both terms. So we can write this symbolically as not Q goes to not P. So we're using the same notation as we did for the inverse, but we're reversing it again. So it's a negated converse. And so this, on the other hand, is going to be true because as a principle, the conditional and the contrapositive statements are always going to be true in any logical context. It makes sense too. If I'm not looking for food, then I am not hungry. So, and this is a true statement. So we have a map. We've mapped out all four different types of basic conditional statements. The base conditional, the converse, the inverse, and the contrapositive. So, and we've mapped out their symbolic notation, and we've also shown the value of each one of them, true or false. And again, conditional and logic statements are key concepts in more advanced geometry topics, because if you're trying to prove a theorem, you're going to use basic conditional and logical concepts in your proof. These are the building blocks of any good proof or reasoning or other kind of statement. And that concludes this video on conditional statements and logic statements as the foundation for geometry.